Now we are talking about the neural regulation and depends on three factors: baroreceptors, proprioceptors, and chemoreceptors. Baroreceptors are for the pressure changes and which is also depending on the stretch in the blood vessels. Proprioceptor is about the movement of the joints and muscles during any action. Chemoreceptors, as the name tells you, is the chemical part, and this controls the concentration of chemicals in the blood. So this input from baro, proprio, and chemo goes into the brain in the medulla oblongata, and from there the messages comes out. So the output can be two ways: sympathetic and parasympathetic. As we know, sympathetic is stimulatory and parasympathetic is inhibitory. The baroreceptor depends on the, as we said, the pressure, but we have the receptors, pressure sensitive receptors in two places: internal carotid arteries and the other large arteries in the neck and chest. So we have carotid sinus and aortic reflex. So reflex from carotid sinus and from the aortic arch. And we have, they are regulating the pressure. One is for the brain, the first one, carotid sinus, is for the brain, and the other one is systemic for the rest of the body. So when the blood pressure is down, the baroreceptors are stretched very less, and the slow rate of impulse goes to the cardiovascular center. So from there the cardiovascular center will adjust. It will decrease or increase depending on the input. Chemoreceptors are very close to the baroreceptors in two places again: carotid bodies and aortic bodies, aortic arch. So one is in the carotid sinus again, and other is in the aortic arch. And they are detecting low oxygen, hypoxia, high carbon dioxide, hypercapnia, acidosis, too much of protons, and all these signals go to the cardiovascular center. And again we have the there, if we see that if we have to increase or decrease, so in that case again the blood vessels will respond. For example, increase in the sympathetic stimulation to the arteries, arterioles and veins will cause vasoconstriction. Sympathetic, remember, is vasoconstriction, and because of that you increase the blood pressure. They also are giving the input to the respiratory center, and we adjust the breathing because of that. We can see here we have the baroreceptors in two places: carotid sinus and arch of aorta, and the message goes, you can see the blue color, the neurons taking the message. Glossopharyngeal nerve number 9 is involved in this. And then we have the output going to the vagus nerve, which can be parasympathetic. And then it goes down to the spinal cord and then to the ganglia. And here we will have sympathetic supply going out, and it goes to the different conducting relays part of the heart, like SA node, AV node, and the myocardium, and it will adjust the heart rate. Hormonal regulation depends on a couple of things. Number one, RAA, renin-angiotensin-aldosterone system. Number 2, epinephrine, norepinephrine. Number 3, antidiuretic hormone. Number 4, atrial natriuretic peptide, ANP. These are all for regulating the blood pressure and the blood flow, and how they do it by 3 ways: changing the cardiac output, or changing the resistance, and adjusting the blood volume. First one, renin-angiotensin-aldosterone system. Renin is released by the kidneys when the blood pressure goes down or blood volume falls. And angiotensin converting enzyme, which is ACEase, it will work on angiotensin 1 to convert into angiotensin 2. So we have this thing finally, angiotensin 2, one of the products, number 1. What it does is raises BP by constriction. So when the blood vessels constrict, it will raise the BP. And secondly, it will secrete aldosterone. Second thing is really in this pathway. So we have two things in this pathway. Again, angiotensin 2 and aldosterone. So aldosterone will, as by the function of it, will reabsorb water. And when you take in water more, your BP goes up, blood volume goes up. So everything comes back to normal. Now remember, this starts only when the blood volume falls. Number 2, epinephrine or epinephrine is from the adrenal medulla and is because of sympathetic stimulation. As we know, this will increase the cardiac output. Number 3 is ADH, antidiuretic hormone, also called as vasopressin. It is produced by hypothalamus, released by posterior pituitary, and it will respond to dehydration. That's the starting point, or decreased blood volume. So what will happen in response to this? We will have vasoconstriction, which will increase blood pressure. And also, so that is one thing of the vasopressin, vasoconstriction. The second part is the ADH. It will reabsorb water. And the reabsorbed water will also increase the BP because the blood volume is more. So vasopressin is for constriction and ADS to reabsorb the water. ANP. This is when you have low BP. This starts from when you have high BP, this pathway. So the cells of the atria will recognize less blood volume coming in. So blood pressure is less. So it will lower the blood pressure. How does it do? It will cause vasodilation and lose salt and water in the urine. So because of that, we will reduce the blood volume and the blood pressure goes down. Now the blood pressure is also auto-regulated. So the tissues can adjust based on the demand of the cells and tissues around it. Okay, so the demand of oxygen and nutrients can increase 10 times during exercise. Okay, and also the regional blood flow in the brain also changes during mental and physical activities. What are the stimulus here? It can be physical, like temperature change, or muscle. Myogenic is the muscle response. And other one is vasodilation and vasoconstriction of the blood supply. Circulation. There are two types of circulation. We know that pulmonary and systemic, and they have different responses. See that systemic will dilate in response to low oxygen, and it will help in bringing more oxygen. But the pulmonary vessels, they constrict under low oxygen so that more of the blood goes to more areas of the lung. Pulse. What is pulse? Alternate expansion and recoil of the elastic arteries. We know very well we have systole and diastole, two things. We have done it before. And this pulse is very strong in closer to the heart, and it becomes weaker as we go away from the heart. Same as the heart rate. If it is more, we call it tachycardia. If it is less, we call it bradycardia. Blood pressure is the pressure in the arteries because of the left ventricle during systole and diastole. So this number is a very standard number, 120/80, and this number can change, and based on cardiovascular or cardiology society, they have different numbers also for different age groups. We measure it because of sphygmomanometer. And we have another concept now. Pulse pressure is when you minus the systolic and diastolic, you get the pulse pressure. This is your systolic, and that's your diastolic. And this is the pressure. The blue line is the pressure in the cuff. So the first sound you hear is at this place, and the second sound you hear is at this place. Shock. Shock is because of the tissues are not getting enough of the oxygen and nutrients. It can be of many reasons. Less volume, vascular and obstructive. Decreased less blood volume, as we know. Plaque, cholesterol, inappropriate vasodilation. It can happen in allergies, for example, or obstruction, and that will be again obstruction of the blood flow can also become what? Less blood volume coming in.